So, in case you don't know me, you may have heard about the amount of energy that Bitcoin consumes. And in a lot of cases, that data is being sourced from my website, Digiconomist, and sometimes alternatively the Cambridge website. They also provide this data, but in a lot of cases it's coming from me. And I've been working on this topic for over 6 years now, I think. I also turned this into a bit of a PhD project on crypto asset sustainability. And what I want to talk about today is how do we build a sustainable Web3. And the first thing that I should address is why do we need to talk about this in the first place? And the best thing to illustrate that with is with one Web3 application that is definitely causing a lot of uproar with regard to sustainability, obviously Bitcoin itself. And as you'll see, these headlines all talk about some effect that Bitcoin or crypto mining has. Maybe we can just take a moment to go through these headlines. First of all, in the top left, EU agreeing on landmark climate legislations. Well, actually, the EU was on the verge of completely banning any kind of trading activities in proof of work related networks, and that narrowly got rejected, and then they came up with increased climate disclosure requirements, which they're going to enforce in their new market in crypto asset legislation. But disclosure seems to be a bit of a trend, but also the US is actively looking to how can we make crypto miners disclose more about their environmental impact. It's a big unknown. I mean, we have estimates, but we want to get information directly from the source about the impact that this industry has on the world. And it's not just the environment. There's also something on electricity rates. When you're adding demand to a grid and you're giving that away to miners, the rest of the grid has to compete for less supply. So you also get rising electricity rates. And you have to make choices. In places like Europe, electricity is getting extremely scarce. You have a limited supply. In Sweden, it's one example where crypto miners are using a lot of renewables, but that's actually a country that doesn't want to have these miners on their grid in any case. So you end up with all of these headlines, and the most shocking thing about these headlines to me is that they don't just have a lot of implications individually, but they were all from the past month except for one. So this is just 1 month of headlines with regard to crypto mining. And I think that really stresses why sustainability is so extremely important in Web3. And before I talk about how do we solve it, I want to address just the magnitude of the problem. Why do we keep seeing these headlines? Well, that's because we're talking about pretty significant numbers. And I already mentioned you can get the numbers on Bitcoin from 2 different sources. You can get them from my own website. You can get them from the Cambridge website. And those are just the live sources. There are smaller live sources. There are plenty of research papers also doing estimates. But in any case, they will all get you to more or less the same range. And that range right now is, at least for Cambridge and my own data source, 81 to 120 terawatt hours of electrical energy that's being consumed by the Bitcoin network on an annual basis, which is more than half of what all data centers in the world combined are consuming. So pretty significant number, though less than before the recent crypto crash. So the Bitcoin price crashed quite a bit, and that has slashed roughly an annualized 60 terawatt hours of electrical energy consumption from the total power demand of the Bitcoin network. That's just talking about Bitcoin, by the way. So you have to realize that right now Ethereum, the second largest crypto asset, is still running on proof of work. So if you were to include that, you have to add 50% on top of these energy numbers. And then, of course, the next question is, okay, big numbers in terms of energy consumption, up to 1% of our total global electricity consumption, but what does that really mean for the environment? Well, in order to figure that out, you need to know where these miners are located, and actually it's Cambridge that primarily tries to provide us with an estimate of where we can find these miners, on which grid we can find these miners, and the result of that is being shown on the screen. This is the Cambridge mining map. They collect information from various mining pools, and they use that information to extract IP addresses, and based on the IP addresses that they find, they estimate where the network hash rate is located, in which countries, and even in which states in the US. And what you see on this map is that there is a pretty sizable chunk in the US, actually over 1/3 of the network, mainly in states like Texas, Kentucky, and Georgia, and of course outside of the US, Kazakhstan is a major contributor, and together those represent around half or a little bit more of the entire Bitcoin network. Having that information is extremely valuable because you need to know where energy is being sourced from in order to be able to say anything about the carbon intensity of that energy. Well, I've worked on that. My own study that was released at the start of this year evaluated what that means for the energy mix of the miners that are located on those grids. And that research shows that on average, the Bitcoin miners have about 25% of renewables in their energy mix. A lot of it is being sourced from fossil fuels, and this changed a lot compared to last year, because previously these miners used to be primarily located in China, where they were physically moving around throughout the year using lots of hydropower during the summer months when it was the rainy season and they had an excess, but then they moved to the north of China using coal during the winter time. But nevertheless, that gave them on average a share of 40% of renewable energy, whereas that got cut after China banned cryptocurrency mining during the spring of last year. And of course, there's also bad news in terms of carbon intensity of mining. Have more fossil fuels, carbon intensity goes up as well. I have a little bit of a breakdown per country, which one is contributing the most to carbon emissions. Actually, Kazakhstan is by far on top here, which is because the Kazakhstan grid is, well, primarily being fed by hard coal. Even worse, they're very inefficient at processing that, so the carbon intensity of that is extremely high. So even though they're not representing a majority of the hash rate in the network, they are representing a majority of the carbon emissions. I have to state that this is the situation of the Bitcoin network as of August last year. It still represents the situation in January of this year, because Cambridge did update their mining map. The one I just showed kind of closely aligns with this map. So the situation is probably more or less the same, but we don't know how this has evolved from January up to now. We're waiting for the next update to figure that out. It could be the case that a lot of these miners have migrated away from Kazakhstan, because Kazakhstan has actually been well, using temporary bans at least to try and reduce mining activities in their borders. We'll have to see about that. But in any case, if this is the situation, and given the energy estimates of this network, we would have to conclude that at the very least the carbon emissions related to the Bitcoin network are going to exceed our total global carbon reductions from deploying electric vehicles around the world. So that's a pretty significant amount of carbon emissions, and that's using grid averages. We could even find a higher number if we were to account for the fact that if you add demand on the grid, what's going to be supplying that additional demand is only rarely renewable energy. In fact, in most cases, because we are in general trying to transition to a greener world, our renewables are already running as much as possible, and any additional demand needs to be supplied by fossil fuel-based power sources. It's much harder to estimate the exact impact, but the number, if you were to account for that, would probably end up being even higher. And then the most controversial number that you can come up with, lots of people in the Bitcoin community tend to love these statistics. when you start trying to figure out what is the carbon footprint of a Bitcoin transaction, knowing that the Bitcoin network is ultimately only handling a very small amount of volume. 100 million transactions per year, which is in the world of digital finance, it's completely negligible. Traditional finance is handling over 700 billion digital payments every year. So in terms of raw transaction numbers, this 100 million would represent 0.012% of that, give or take a little bit, depending on how you count the numbers exactly. In any case, this is what gives a single transaction really extreme footprints. And I listed some of those footprints. And obviously the most relevant one is going to be the ultimate carbon footprint of a transaction. And what we see there is that that number can exceed sometimes 1,000 of kilograms of carbon dioxide. And recently, thanks to the price crash and miners shutting down, that footprint has gone down as well. So now we're talking about just a little bit over 800 kilograms of carbon dioxide per Bitcoin transaction, which is a massive number still. If you were to compare to anything, just consider that if I were to take a flight from here to New York, the carbon footprint of that flight, at least my per passenger contribution, would be still less than 800 kilograms of carbon dioxide. So in terms of emissions, it probably pays off to just take your money from here to New York by plane rather than sending it over the Bitcoin network. And then, of course, you have to consider electronic waste as well. If you ultimately have, well, you have this network which is running on highly specialized equipment, that equipment tends to become obsolete rather fast, and it's likely that that just means that ultimately that results in, you know, you discarding on average the equipment weight of more than 2 iPhones per transaction on average. Again, just in terms of equipment weight, which adds on top of the carbon footprint of a transaction. So I already just mentioned electronic waste as a concern that adds on top of the energy consumption of the Bitcoin network. But that's not it. We see a lot of cases where these miners are flocking to the same locations, and it strains local grids, sometimes to the extent where the grid becomes so unstable that it results in blackouts. But more frequently, the impact that it's going to have on locals is that it's going to increase their energy bill, for the very simple fact, you know, it's basic supply and demand. If you take a big chunk of your supply and give it to miners, the rates for the remaining supply are going to go up. And worst case, but that's in the case of poorly managed grids, you can end up with blackouts as well. And there's a lot of other consequences than you should think about, like even noise pollution is a thing in some locations where the humming of these mines is affecting local wildlife and other locals in other ways. But yeah, that's just all adding on top of, you know, the main impacts, energy consumption and electronic waste. And of course, not just electronic waste, but also think about all the chips you need to make these specialized machines in the first place, eating away at our global semiconductor supply chain, which was already under strain over the past years as well. Okay, now, starting to get towards working towards a solution. Proof of work has a big impact, very closely related to the asset value of those assets. So the reason why we talk about Bitcoin the most is simply because Bitcoin is the most valuable proof of work system. If Ethereum, which is today still was running on proof of work, or they are running on proof of work, but if they were more valuable than Bitcoin, they would have the largest impact on the environment. So one solution to this problem is change the mining algorithm. Actually, get rid of it. which is something that you should never say in the Bitcoin community, but it's something that the Ethereum community is actively working on. They're working to replace their proof of work with proof of stake, and if they succeed, they could potentially reduce their power demand by a factor 10,000. And why is that? Well, when you're mining, what's happening is that the whole processing of transactions in new blocks for the blockchain is dependent on very energy intensive machines that ultimately do nothing more than playing a massive game of guess the number. In order to create the next block for the Bitcoin blockchain, your machine needs to guess a certain winning number, and only if it guesses correctly, it gets to add that block to the blockchain. And adding a block to a blockchain is nice because then you get rewarded for that with currently 6.25 Bitcoins. That reward is available currently on average once every 10 minutes. But you have a network that's making 200 quintillion guesses every second of the day non-stop in an effort of trying to find that winning number. And that's obviously where all the energy consumption is related to. It's really that process of guessing random numbers. Whereas every incorrect guess, almost every single one of them is just immediately discarded. In proof of stake, you get rid of this process for the most part. You still keep a lottery, but what happens is that you don't need any very powerful equipment to participate. In fact, what you need in proof of stake is you need to acquire coins, and you need to put those coins up as collateral in the staking process, and then the algorithm itself will randomly select one of the stakers to produce the next block for the blockchain. The only thing you need for that is a device, any device with an internet connection, and of course the most important thing is you need to acquire more coins, and the more coins you have, the bigger your chance of winning, whereas in proof of work, the more machines you have, the bigger your chance of winning. So doing away with that, going to proof of stake, can probably eliminate 99.99% of the energy consumption. Although I have to add two things to that, which is that measuring the exact levels of energy consumption in proof of stake systems remains very tricky. There is no clear defined methodology to do it. Actually, a lot of academics, they don't focus on proof of stake, they do proof of work because the numbers are going to be bigger and it's easier to estimate. But proof of stake, well, if you can use any device, and it doesn't matter which device, you can assume people are going to be using the most efficient device, but your error margin can also be a lot bigger. So we don't know exactly how the energy consumption profile of proof of stake will compare to proof of work, but that there is going to be a significant reduction is definitely certain. Just because, like I said, you're not dependent on computationally very power-intensive hardware, very powerful hardware to participate. One other thing I should add is that it's not just a matter of, environmental sustainability when you're making a switch like that. Obviously, these two different versions of software also have different implications in terms of, for example, how your security model looks like. You may have all heard that, if you want to attack a blockchain network, you need to acquire a majority. In proof of work, a majority of the hardware in the network. Majority attack is one theoretical attack. Getting a majority of the hardware is very different from acquiring a majority of the coins, which would be something what you'd have to do in proof of stake in order to execute a majority attack. Which one is easier is debatable, but in any case, there's more factors to consider than just the environmental side of things, although obviously the environmental side is undebatable in the sense that proof of stake does consume a lot less than proof of work. But whether it is the ultimate solution to proof of work remains to be seen. One other thing you can do is you can permission your blockchain. Bitcoin and Ethereum are permissionless systems, meaning anyone can participate in the network. But hey, if you're building a Web3 application, why would you have to build on a public proof of blockchain like Ethereum? You can, if you want, you can build your own blockchain, and you can make it whatever way you want. And if you limit the amount of participants, for example, then that's also going to limit the amount of devices that are going to be active in this network, which can significantly reduce your energy consumption, even compared to a proof-of-stake network, because public proof-of-stake networks, they're still open systems. Anyone can participate, and if there's hundreds or thousands of machines, that's still going to be less efficient than when you have a very permissioned system with just a few dozen of active validators. Very big other consideration that you will have to make in that case is, if I'm going to cut down on, let's say, the amount of participants, if I'm going to limit that, am I not introducing a very high level of centralization in this network? Because obviously, the less participants, the more centralized the network is going to be, and to what extent do you still have the decentralization that you wanted blockchain for in the first place? So, different consideration, but again, at least on the efficiency side, the energy efficiency side, it's a very easy one. But this is where you really have a choice whenever you're building a Web3 application. You can choose from different public blockchain networks. Some of them are already running on proof of stake, or you can just build your own platform and maybe choose to limit the amount of participants. You can significantly reduce the energy requirements of whatever application you're building through these choices. But at the same time, it's not so simple as just reducing the energy consumption. You also have to contemplate many other things, such as scalability and security. And going with the more energy efficient solution might result in you sacrificing on other properties, such as scalability, or maybe increasing scalability, but still sacrificing on security. The bottom right picture is, by the way, from a study that was, I think, released 1 or 2 years ago. I had no involvement in that one, but I thought it was a nice image, just because it illustrates not just the difference between proof of stake or non-proof of work public blockchains and proof of work public blockchains, but also showcases what I just said, having an enterprise blockchain, a permissioned limited blockchain, is also more efficient than having a public non-proof of work based blockchain. But again, by limiting the amount of participants, you're sacrificing on central or decentralization, meaning potentially also sacrificing security. So these are tough choices that as a developer you have to navigate. But I think the good news is, if you're building these applications, you can circumvent the energy problems that have resulted in the headlines that you see for Bitcoin, and you can circumvent the headlines that have, for example, led to recently the WWF, the World Wildlife Fund, having a major PR disaster as they launched NFTs on top of the Polygon network, and then later realized that actually Polygon is very closely tied to Ethereum and therefore still very dependent on an energy-intensive network, so not as sustainable as people originally thought. So it's a bit of like navigating a minefield sometimes, because finding out this kind of stuff is not always very straightforward, especially not when you have, in the World Wildlife case, the Polygon network claiming that they are perfectly sustainable because they're just running on proof of stake, while in reality they were closely tied and still are closely tied to the Ethereum network. And they recently started doing some carbon offsetting for that as well, but that was a bit too late. So yeah, I guess this is the good news. You have a choice. The bad news is it's not an easy one. So there are many factors to consider beyond the environmental side of things. I'm hoping to have at least given you some food for thought about that. Last thing that I want to talk about is how I intend to contribute to making more sustainable applications, or at least cleaning up your existing applications. For my own energy index, I have 3 of them: the Bitcoin energy consumption index, the Ethereum energy consumption index, and the Dogecoin energy consumption index. because they're the biggest proof of work networks. Dogecoin is not that big, but at least relevant enough to consider. And I've just launched an API with some information that you can use to size your environmental footprint when using these networks. So what you can retrieve is the energy consumption and the carbon footprint of a certain network on a certain date, and you can retrieve certain base levels of or certain base units for the environmental footprint, being, for example, in the Ethereum network, the carbon footprint of a unit of gas, which is typically used to, for example, size the footprint of an NFT. I mean, just to name a possible use case. And for the Bitcoin network, Dogecoin network, they're not running on gas, but in that case, you can use the carbon footprint of an output to help you size the carbon footprint of a transaction. What I previously showed at the very beginning was the carbon footprint of a transaction on average, but in reality, transactions can represent transfers to either one person or many different persons, and if you weigh that by the number of outputs, you might be able to get a more realistic picture of your specific transaction. That was the content I had for you, and I hope you have a few questions to ask. But yeah, that's it.